Uh, Yesterday we were discussing about input and output functions in C. Two categories of input and output functions: unformatted input output functions and formatted input output functions. Unformatted, we saw getChar and putChar for accepting character from the user and displaying a character to the user. And there are other functions also. For getting a string we have getAs function, then for displaying a string we have putAs function. But since it is not part of the syllabus, we are not learning it. But it is pretty straightforward, simpler than printf and scanf. Now, formatted IO functions, printf and scanf, can be used for all these data types. So getting a character or displaying a character, or getting numbers or displaying numbers, or getting strings, displaying strings. So this can be used for all data types, but this function is specific to a data type, character only. Then getAs is for getting strings only. But the syntax is simpler. Here we don't need to specify the format and all. There is no format string. Variable will be returned by the function. No, data will be returned by the function and it can be assigned to the variable like that. So it is usage wise it is simpler, but if you know printf and scanf syntax properly, most of your job can be done with this. But still it is there in the syllabus and we need to, there can be questions in the exams, so we need to understand the unformatted IO functions also. Okay. Then we saw some supporting function like to upper, to lower. To upper will convert a lowercase character to uppercase character and return that. Similarly to lower, if the input is an uppercase character, it will convert it into lowercase and return it. Then is alpha, is digit, etc. Two functions we saw. Whether the character we are inputting, whether it is an alphabet or not, is alpha will tell. Is digit will tell whether it is a digit or not. Okay. The other option is not alphabet, not a letter, not a digit. That means it can be a symbol also, hash, dollar, etc. Okay. From there we are going to formatted input function, that is scanf function. Okay, we already know how to use scanf in most of the cases. Little bit more we will see. That's it. Okay. So why we call it as formatted function? When we call the function itself, we specify which format, or in the sense what type of data we are expecting and how many such data item we are expecting. So we use %d. So the general syntax is like this: scanf, there is a control string. This will be made of %d or %c, %d, a mix of such control strings or format strings. It says what is the data type what are the data types we are expecting and how many data items we are expecting. And here we say where to store this data entered by the user. So the variable names we specify prefixed by ampersand. The example is here. So this format everybody is comfortable. You must be comfortable with this, because every program is going to have a scanf statement as well as printf statement. Okay, almost every program in your lab or anywhere you are going to do in C. So this is the specific example, and the general format is like this. First argument, or argument 0, I can say. First one, say string because it is enclosed in double quotes, and within that we specify placeholders or format strings to indicate number, integer, indicate character, indicate a real number, and separated by single space. No space here, no space after. Okay. Then the variables. This you are comfortable. You have used it many times, and if you are not comfortable, you practice it more and more times. Now for the format string, this part we have some specializations actually. Okay, little bit specialization is there. So this is whatever we have used is a specialized form. The general form is this one. Instead of so now will come specific to integers. we are using percentage D everywhere so far, but the general format is percentage WD. The W stands for width, some sort of width. Width here, what it means is the number of digits we want to read. If I specify percentage D like simply like this, it indicates the whatever number entered by the user, if that can be accommodated in this variable. Variable has a size allocated to that. So if that can be accommodated into that this variable, everything will be read. If now 5 digits are there, you are entering 5 digits. All the digits will be read, stored into this variable. But generally, we have some control over that. We can put a parameter called W. We can specify a parameter called W. It stands for digit width. W stands for width, and the meaning is how many digits we want to read. Okay. Now an example is here. W value is 5. W is a general representation. It is for width. There in the place of that we will be specifying a number. Now here it means whatever may be the length of the number user enters, out of that only 5 digits we are going to read. And first 5 digits we are going to read and we are going to store in this. That is the implication. So reads, if we are specifying scanf statement in the general format percentage WD, in place of W if we specify 5, it means out of the digits entered by the user, from the number entered by the user, if only first 5 digits will be accepted and stored in this variable. That is the implication. Now if you are simply putting maximum possible digits will be stored, accepted and stored, maximum possible digit. Maximum I say because num1 has a size, it may be 2 bytes or 4 bytes as allocated in the memory. So the number accepted should be able to store in that. We should be able to store that number in the 2 bytes or 4 bytes. So if you are entering 10 digits or 15 digit number, all of them may not be read. But within that maximum, all the digits will be read. If you are specifying simply percentage D. Percentage 5D means only 5 digits will be accepted. We will see the example. So I have an example here. Asking to enter 6-digit number and we are using percentage 5D. We will directly go to that example. Yeah, it is here. So asking the user to enter 6-digit number and we are specifying percentage 5D. So if user enters 6-digit number, what it is accepting is only 5 digits, first 5 digits. Now instead of that, if I simply specify percentage D instead of percentage 5D, and if I enter a 6-digit number, all of them will be accepted. Okay. Here we are able to put a small control on how many digits are accepted. Okay. So what is the practical application? It is difficult to specify one. Whether we are going to use this feature anywhere, it is difficult to tell. Okay. When I am not able to figure out a scenario, that the only thing is that if the user is mischievous, he is entering so many digits and somehow we want to restrict and read only a part of it, we can use this. Okay. That way. Now one scenario can be you want the user to enter a 3-digit number. You are asking to enter a 3-digit number, and user may be, or you are asking an user to enter 2 3-digit numbers, and user may skip the space in between. In that case, we can read only 3-digit number like this, the first 3 digits, and one more time you issue scan of percentage 3D, you will get the next 3-digit number, 3 digits. That way we can read. That is one possibility. So I can show that example here probably. Now I am asking user to enter 6-digit number. Okay. So 1, 2, 3, 4, 5, 6. User enters 6 digit. Now first time what I am doing is I am accepting 3 digits only. So first time when I am reading, A is assigned with 1, 2, 3. So that's why we are getting 1, 2, 3 here. Now one more time I am issuing scan of percentage 3D. The remaining 3 digits will be read. See now even though user enters 6 digits, I am getting first 3 digits separately, remaining 3 digits separately. I can store it in a different variable B and I can use it simultaneously in the program. So this kind of scenarios we can use this feature, specifying how many digits we want to read from the user. Okay, any question?
So we use Anderson symbol in scanf but not in printf. What
Yeah.
happens if we use that?
Somehow as of now you understand that in scanf only you will specify in every time when you want to display a value you will not specify ampersand, but whenever you want to read or use scanf you have to use that is by rule of the language. I can say as of now. Now if you know little bit technically, you have studied C before, I can say what I am passing into this function when I am putting ampersand, I am passing the address of this variable, because in memory every byte, every integer will have some address, right? I have shown in that vertical structure where we are byte wise the memory layout I have shown. For every byte there is an address. So what I am doing is I am passing the address into this function. So that scanf function knows in memory where A is allocated with 2 bytes or 4 bytes, and scanf function will put data directly into the memory. Okay, what I'm doing is passing the address here, but when we want to display the value onto the screen, printf we are passing the value itself we are passing. When I'm doing A, it refers to the actual value. When I'm referring ampersand A, I refer to the address of A. That means in memory, in which address, which bytes where the memory is reserved for, allocated for variable A. If you did not understand anything now, we will when we go to the last module, we will study about pointers. There it will be it is possible to understand. Otherwise, we are simply to know that what we are passing is memory address of variable A is what we are passing into this function. But printf does not require that. Printf just require the value stored in this variable. So that's why we are passing A. Clear?
Yes, sir.
If not clear also, don't worry. When we are learning the fifth module, fifth unit, it will be clear. Okay. As of now, for those who are new to programming, memory address pointers and all, if I say, they may not be able to understand. That's why I'm not bothering too much. As of now, they can simply think that scanf, the syntax is like this. The rule is like that. We have to pass the address. But if it is an array, character array, we don't need to pass also. That I only in case of character array, we don't need to use ampersand in scanf. That also I can explain probably in module 5, so that that time you will have better grip on the topics. Okay. We'll continue to the next slide. So percentage WD is the general format for reading input into your program, but mostly we will be using percentage D only. Very rarely we will have to use percentage WD. Okay. Here one thing, one special use of scanf here. So what it does is, see in the control string, percentage D, percentage star D, percentage D, and here I am specifying only two variables, even though there are three control strings here. This one is a special type. What the use for that is, we want to skip the middle number. If user is entering three numbers and we want to skip reading the middle number, we want to read only first and last numbers, then we can use percentage star D. Okay, in this case, in first number entered by the user will be stored in A, last number entered by the user will be stored in B, and the middle number, if user is entering three numbers, like this, middle number will be skipped. So if user entered 10 space 50 space 100, 10 will be stored into A, 100 will be stored into B, and 50 will be skipped by the scanf function. Okay. Again, very difficult to find a practical application for this. Probably when we are doing more and more programming, we may encounter with the scenario like we want to skip some data entered by the user in between, and we are specifying like this. Okay. So this will skip the middle number. If user is entering 3 numbers, the middle number will be skipped. In that case, you need to specify only 2 variables here, where first number should be stored, where the third number should be stored. Then we'll go to next one, real number. So far we are seeing percentage D inputting integers. Now what about floating point number and double type real numbers? Okay. So generally we know what is the syntax. If we have 3 float variables and we want to read 3 floating point numbers, percentage f space percentage f space percentage f. You can omit space, but the most recommended thing is put a single space there, not more than one space. Okay. Now the general format again. Here also the general format is percentage f wf only, similar to integer percentage wf only. Here w again indicates width or the number of digits. Basically w stands for width. Here the meaning is w specifies the width of the data to read including the decimal point. Okay, including decimal point, the how many characters are to be read. So decimal point is not a digit. Previously integers there can only be digits, but when we are entering a real number there can be a decimal point also. So here w specifies how many characters to be read including the decimal point. Okay, otherwise the meaning is more or less similar only. We can specify how many characters to be read. There also it was characters only, but characters happen to be digits only. Okay, here character means decimal point is also involved. Otherwise same application, percentage wf we will specify instead of. So percentage wf instead of in place of w we will be specifying a number typically. Now coming to the strings, we have seen some programs in the lab, and I already told multiple times, for string we need multiple character variables, and instead of declaring multiple character variables, there is a simpler way, creating a set of character variables. str 10 character variables I am creating here this way. This is also called a character array. That means an array of character variables. In C there is no data type, built-in data type for storing string. So to store string, what we are doing is create multiple character variables, and each character variable store one character each. That way in a string all the characters that are part of the string we will be storing it together. In first byte, say if it is hello, in first byte h will be stored, in second byte e will be stored, or in second variable, in third variable again l will be stored. Like that we are going to store. To create a set of character variables together, this is the syntax. Char the variable name in square bracket 10. This indicates 10 character variable we created. If you want to access the first character variable from this set, I can simply specify str of 0. This refers to the first character variable. str1 refers to the second character variable. Now if I am storing hello in this character array, in this array or set of character variables, h will be stored in str0, e will be stored in her1, and again l will be stored in her2. Like that it is going to get stored. Okay, now Once we create a character array for storing a string, we have to use the format string percentages, and str only we need to pass, no ampersand str. Okay, this is an exception. In fact, everywhere else, when we are reading one data item at a time, we will have to pass ampersand. But here we are reading a set of data items, set of characters we are reading. In that case, only we can omit this ampersand. Okay. Now the general format is again percentage %ws. This W says how many characters are to be read, accepted. Similar meaning only come in both integer, real numbers as well as string. The general format is percentage %ws, where W indicates how many characters are to be accepted into the variable we created, in the array of variables we created. Okay. Now let me see if I have an example. Okay. I have an example here. So the rest of the things I'm commenting out. So enter a string. The whole thing. If I'm not specifying any digit here, whatever I can since str20 is used, I can store up to 20 characters in this str. 20 indicates the size of the array, character array. That means how many characters we can store. So up to 20 characters I can store. If I'm not specifying any digit, I'm going to it is going to read all the characters, all the characters it is going to read, and I am displaying here the string is %s and str is the variable we need to. Now if I specify a digit here, say 5 I am specifying, and again I am going to run, I'm going to input a longer string. Welcome has 7 characters. It is reading only 5 characters because I specified 5 here. Okay, like that. If I specify 10, it doesn't make any difference, so it will read all of them. As long as the entered character is less than 10, it is going to read all of them. Okay, if it is exceeding 10, only 10 characters will be accepted. Okay, so if I don't specify anything, all the characters until a space encountered, all the characters will be accepted. Simply S means all the characters entered by the user until a space is appearing or until 20 characters. Okay, legally only 20 characters I can store in this because this character set consists of size 20 is made of 20 size. That means only 20 characters I can read. Now I will show an example here. Hello world. It is reading only hello because whenever a space is encountered, scanf function will stop reading, and that hello will be stored in str, that will be displayed. Okay, now even if I am specifying 10 here, hello world, only hello is, so whatever digit I am specifying or the space character, whichever is coming first, either 10 characters or the space character is appearing, whichever is coming first, until that only will be accepted. Okay, this is a limitation with the scanf %s format, that only until a space will be accepted. Now if I want to accept the remaining thing, one more scanf I will have to. Now if I enter a string, say Tojo Matthew, only Tojo will be accepted. For Matthew, one more scanf may be required. Okay, so I can issue this one more time. It will be overwriting this, or I can create another variable, say str1. str1. So here I'll scan into str1. Okay, now I have issued scanf 2 times and I am displaying both the strings. I am trying to read 2 strings and my input is hello world. Now what will happen? Hello will be stored into str and world should be stored into str1. Okay. Okay. Now again it is not working as I expected, because again there are some issues with this scanf function and all. So it is not working as I expected, but ideally that should be the scenario. Okay. Now again one more disclaimer: the scanf function and printf function, sometimes it may behave little weirdly. We'll expect certain fashion. It is not very consistent stable function, I would say. Okay, scanf and printf function. So that's why I say use give exact. If there are multiple things, you give exact one space in between. Especially when it comes to reading strings or a set of characters or strings, the scanf function sometimes behave little weirdly. So that's why it's not happening as I expected. Okay, for that I will have to do some other gimmicks. Okay, uh, okay, that will not take up now. Now there is a clear limitation that if I am reading using percentage %s only, uh, until a space it will be reading. Okay, there is a clear limitation. Until a space it will be reading. Okay. Now if I ideally when I enter issue one more scanf, it should be reading second, but it is not functioning properly. Now how to overcome this limitation? There is another format for reading a string. Instead of using percentages, there is another format string. I'll go to that. Here you see percentage %5s will read the first 5 characters from the string. There is another format, percentage in square bracket, a symbol, caret symbol, upward pointing arrow, I can say. Okay, it's called caret symbol followed by slash n and the square bracket closed. So instead of percentages, I can specify this. Okay, so if you specify that until this is a slash n character, new line character, we have already seen what is the use of new line character to insert a new line onto the screen. Now if I specify this until new line character is appearing, until that time until that all the characters will be accepted. Until a new line character, this will read until a space is appearing in the input string. This will read until 5 characters in the input string. This will read until slash n appears in the input. So I will change now percentage square bracket caret symbol slash n. Square bracket I should output. Okay. So this is another feature supported by this compiler, but this may not be supported by all the compilers. That again disclaimer is there. Now what I am doing, instead of percentages I am specifying square bracket, this caret symbol followed by slash n, square bracket closed. Now if I execute, it will read. What is happening? After entering this many hello world, I am pressing enter key. When enter key is pressed, actually what is getting inserted is slash n. Okay, enter key is equivalent to putting a slash n. So when enter key is encountered, until that point of time, whatever characters I entered, all of them are read. Now if you want to read a first name last name format, Tojo Matthew or Rohit Sharma, okay, you can use this way. when you are doing a programming, you want to read. Then another option is there is a function called getS. GetS function you can use. You can see the syntax of the not zero. You can see the syntax of getS function. So that will also read, ignore the space, and it will continue read until the end, until the slasher. Okay. So generally what we're talking about, percentage WS is the format. W stands for number of characters. So that many characters will be read, or until a space is encountered. Only one word without space will be accepted in this way. Now if you want to accept multiple space also, until a complete line of string or line a sentence, for complete sentence, you can use this format, but this may not be supported in all the compilers. Your online compiler, I'm not sure, you can just try it out. But in code blocks, the compiler we use is GNU-C compiler. In eBox also what we are using is GNU compiler. This seems to work there. Okay. And the instead of /n, if I put x, until x is encountered, it will read. All the characters before x, it will read. If I specify a, all the character until a, it will be reading. So I can see give an example. Instead of /n means until /n, all the characters are going to be accepted into your program. I am specifying a, and what should be happening, until a is encountered, all characters before will be accepted and stored in this one. That is what we are expecting. Okay, so I am going to put, so a is appearing here, so you can see what is the output coming. A is not accepted. In previous case, when I put /n is not accepted, but all the characters before /n was accepted. Here a is appearing here, so all the characters before a, all the characters are accepted. That way. So yeah, it's of some good use whenever it comes to reading a string into your program. Any question? So we have till what time? 12:30, right? No, 12:40. So we have some more time. Yeah. So we can finish probably this topic today. Now detecting errors in errors in input. So this is something new that we did not discuss so far. When I'm calling scanf function, what happens? The data entered by the user will be stored into this variable. There is one more thing happening. Scanf function returns some value. Scanf function returns some value. If I want, so far I was ignoring that, but if I want, I can store that in a, and what it returns is an integer. So if I want, I can store it in a variable. So far how I was using simply called scanf. Enter some data, then scanf like this. But in this case what I was doing is the value returned by scanf function I was not storing in a variable, because I was not interested in that data returned by the scanf function. In fact, scanf is returning a integer value which indicates how many data items out of this. I am expecting 3 data items. Out of these 3, how many are successfully accepted and stored in these variables? That is the how many are successfully accepted and stored in the variable. That is the indication of the return value integer from the scanf function. Now if I want, I can store it in a variable. I can store it in a variable. Okay. So based on that, I can get a best guess or inference whether the input was correctly taken into our program, and we can do further processing. Just an indication I can get. I was expecting 3 data items, whether I got all the 3 data items, that such an indication I can get. Okay. So now when scanf function is executed, I get a return value which is an integer value. I am expecting 3. I can compare whether D is equal to 3. If D is not equal to 3, I can conclude that there is an input error. All the 3 data items are not successfully accepted to my program. If all the 3 are successfully entered by the user correctly and successfully accepted into my program, D value should be 3, since I am expecting 3 data items here. So I check, if D not equal to 3, I will print input error. Otherwise, I can conclude that there is no input error. Okay, I'll show the example. So what this program is expecting, first an integer followed by a character followed by a real number. So I enter an integer followed by a character followed by a real number. So how many inputs? I am storing the return value of scanf in a variable and I am printing the value of D. The return value of scanf, inputs equal to 3. So all the 3 inputs came. So I compare against D not equal to 3, I display error message. Otherwise, I display no input error. So what is printed is no input error. That means all the 3 inputs are entered by the user correctly, and we are able to read those data into our variables correctly. Okay. Now next time when I am executing, even though I am expecting an integer first, I am not going to put an integer. I am going to put a string. Okay. Why always my name? So I am going to put a string followed by a character followed by a real number. In this case, inputs is 0. That means in the first data item itself, an error was encountered. So the remaining data items also not correctly accepted into my program. First data item, I was expecting a number from the user, but that did not happen. That means remaining things also ignored. The compiler scanf function ignored the remaining data items also. So inputs is 0. So we are expecting 3. 0 not equal to 3 is true. So error message is displayed. Now if I put another input, first one I am giving correctly, second one also I am giving correctly, third one I am giving a string. Now first one is correctly read, second one is correctly read, third one when it came we are expecting a real number but the user entered a string, so error happened. So the return value of scanf function is 2, indicating that only 2 data items, that means first 2 data items are read successfully, third data item is not read successfully. We are expecting a floating point number but string was entered. This way minimal error checking in the input we can do. Whether the input has come correctly or not, entered correctly or not, we can check using the return value of. So far we were not using it because we were expecting, we ourselves were in giving the input, we are expecting expecting to enter the data correctly, but this way is also possible to check the error. Okay. Then similar to scanf, printf also returns something. Printf function also returns something. This is something additional. What it returns is number of characters successfully displayed onto the screen, or number of printf is displaying some message onto the screen. So how many characters are displayed onto the screen is returned by printf. Now here I am storing the return value of printf into a variable and I am printing that variable value. So I will run this program. So a number, a character, correct input we are giving. Okay. Now no input error. Okay, that there I think I should give a wrong input, then only I will enter here. I should give a wrong input. So I'll put a input error is there. So it is saying printed 12 characters. Printed 12 characters. What is that I am printing? I am printing this message, input space error slash n. This, and I am storing the return value of printf in variable c, and I am printing the value of variable c, printed %d characters comma c. So 12 characters I printed, I am getting. So this is actually 12 characters. If you count this, it is 12 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Slash n is a single character, 12 characters. Okay, printf returns 12 characters here. This printf message. So similarly, this printf returns how many characters are here. How many characters are here. But here we are not interested in the return value, so we are not storing the return value. Any question on that? Okay. Formatted output. So now we are coming to formatted output. We are discussing about formatted inputs so far, integers, real numbers and strings. Then mixed output, formatted reading mixed input. Mixed input, we already know this %d, %c, %f. Mixed input means different data types we want to read. Not only integers or not only floating point number, different types of data we want to read. We'll specify the variables and the format string accordingly. For an integer, we specify %d, character, %c. This we already know, so we don't need to. Only thing is that we are mixing up data types, and in one scanf statement we are reading. When we are doing this with the string, so it may not work properly, but other built-in data types like %d, %c, character, integer, real number, this will work properly. Okay. When you try mixing up data types in with along with a string, along with the percentages, scanf may not work that well. Okay. We'll move on to formatted output statement. Formatted output statement. We had just started with that. Basically, we all know the function we use for formatted outputting is printf statement, and the general syntax also we know, printf control string, and followed by the arguments. So this will be normally a variable or a constant or an expression, like compound expression. So if formatted output supports user-friendly formatting, like the sum of certain number and certain other number is this. Like that we can format our output, and these %d act as the placeholder where the values of a, b and sum will be placed. Value of a will be placed in the place of %d, first %d. Value of b will be placed in the place of second %d, in that order. Okay, %d, %d. First one will go to the first %d, like that. This is similar for character displaying, string displaying, floating point number displaying. This is similar. Okay. Here are some examples we have seen. So if I simply print a message like this, hello world, it will come as such on the screen. Then an empty string or a blank space, we can print like this. New line will simply, this character won't be printed, but its effect will be there. There will be a one blank line, or if you have already displayed a message on one particular line, next message will come in the next line. That's why this blank slash n printing. So slash n we can use within a string also. Within a string constant, if I use a slash n, then hello will be printed on one screen, world will be printed on one line. Hello will be printed on one line, world will be printed on next line, because of this slash in between. Otherwise it will come like this, hello world, if it is no slash n but a blank space. Okay, so if I do this, it will come this way. Okay, how you are giving the argument, first argument, the same way the output is going to be there. Then tab is a group of blank spaces. So if I put a tab here, So there will be more space. Normally tab represents four blank spaces or sometimes 8 blank spaces depending on the configuration of your screen. Okay. Now the general format for formatted output also, in outputting integers, if we take the general format is %WD. Input scanf for scanf of scanning or inputting integers, that time also we learned it was %WD, and there W stood for width or the number of digits that will be scanned. So if you are entering a 6-digit number, but W you are specifying as 3 %3D, then only first 3 digits will be taken as the input. Remaining 3 digits will not be taken as the input by that scanf statement. So if you want to read the remaining 3 digits also, you may have to issue one more scanf statement. Okay. So here slight difference is there. When we are displaying %WD, W width means how many spaces need to be reserved on the screen, or I'll say specify minimum field width for the output. Minimum field width for the output. So if I am specifying W as 6 spaces will be reserved on the screen. So what it means is your screen or monitor is monitor is divided into a grid actually. Okay, logically divided into a grid in this fashion. Here you see horizontal and vertical. This is organized as a matrix or a grid, right? So this one square block is one space. Normally one character will be displayed in this cell. I can say one cell. This is another cell. So if you are displaying hello, H will come here, E will come here, L will come here, like that. Or if you are displaying 1, 2, 3, 4, 1 will come here, 2, 3, 4, etc. Now when we say %WD here, how many such cells are to be reserved for displaying the number? That is the implication. Now if I put %6D, 6 cells will be reserved for displaying that particular number. Now what if that particular number is not 6-digit number? I am reserving 6 spaces, but if that number is not 6-digit number, still that space will be reserved. Suppose it was a 4-digit number, 4 cells will be utilized and remaining 4 cells will not be utilized, or two cells will not be utilized if I am reserving 6 digits, 6 spaces or 6 cells. So W stands for how many cells are reserved on the monitor display grid, and depending on the number of digits in the number we are going to display, that cells will be utilized for displaying it. Okay, I will show an example here. I have mentioned simply %D, no %WD format. I have used simply %D. So in that case, based on the number of digits in the number, cells will be reserved and it will be displayed accordingly. So the number has 4 digits, so it will display. It will reserve four cells on the monitor grid, and in each cell one digit will be displayed. That way 9876 will be displayed. Okay. Now I am reserving, instead of W, for W I am specifying 6 as the value, %6D, and the number I am specifying is a 4-digit number 9876. In that case, how it will be displayed is this way. Since it is 6 here, 6 cells will be reserved on the screen in the monitor grid, and the number will be displayed in a right aligned manner. 9876, only 4 digits are there. So anyway 2 cells are going to be free. So how the number will be displayed is in a right aligned manner. So it is towards the right, it is aligned. Okay. Now by default it will be right aligned manner. if it is percentage 60. Now if I put percentage 2D and the number I am specifying is more than 2. Now 2 cells I want to reserve, but the number I am specifying is more than 2, that means 4. In that case, the number of digits in the number we want to display, that will take the priority. Even though 2 cells we want to reserve, since the number is having higher number of digits, higher number of cells will be reserved and all of those cells will be occupied. The output here in this case and in this case, it is going to be same. So if you specify a field width uh, smaller than the number of digit, this number will be ignored effectively. Okay. Now here it is right aligned manner. When we reserved more cells than what is required, it is displayed in a right aligned manner. Suppose we want to force to display it in a left aligned manner, we can specify percentage minus 60. Now this minus indicates the number should be displayed in a left aligned manner towards the left. It should start from left extreme. So if I want to display it in that way, I can specify minus 60. So 9876 and the last two cells will be left free. Okay. Now another one more format, percentage 060. Now percentage 60 right aligned manner, by default it is aligned. Minus 60 left aligned manner. 060 it will be displayed in a right aligned manner and the blank cells will be filled with zeros. How many blank cells are there? It will be filled with zeros. Okay. Now this is for say, long integer we use percentage LD, short integer we use percentage HD. Okay, that is we can use it, but instead of percentage D we can use this format string, that is different. So this is the way we display minus 60 or minus we use when we want the number to be displayed in a left aligned manner, or 60 or positive 60 plus 60 the default behavior is right aligned. Any question in that? Well,
Sir,
sure.
suppose
Yeah,
if we consider to type more numbers rather than six-digit number,
yeah,
and even then we type as percentage 6D in the printf, what does it? You said that six slots would be reserved,
yeah,
but the number we have chosen as an example is more than that.
yeah.
So
Here,
only
here I have an example here. Percentage 2D and see two cells are reserved. Now number I am specifying is 4 digit. So this is the number of digits take the priority. So in that case, this will be ignored and how many cells are required, that many cells will be utilized. Is that your question?
yes, sir.
Okay. So we'll see an example, the same example we'll see. So I'll just take it. Now the first one, I'm not specifying any W value, 9876, 9876. Second one, I am specifying percentage 6D. So 6 cells are reserved and the number is displayed in a right aligned manner. So this initially 2 cells are left free. It will not display the cells as such, but it is logically, invisibly it is there. Okay. Now third one, percentage 2D, and I am passing a 4 digit number 9876. So reservation of 2 cells is ignored. Instead of that, whatever cells are required, it is utilized, also reserved and utilized. Now fourth one is left aligned manner. So minus 60 I used. So you can see that it is displayed in a left aligned manner, and two cells are actually reserved here. Actually, two cells are reserved here, but that will be visible when we are displaying the next number. Suppose I am removing this slash n here, because slash n I inserted for having a new line. I'll remove that and I'll run it again. Now you see, after the fourth display message, this one, next message is along with the zeros. So that is coming here. So that means here for the first number 6 spaces are reserved. And out of that, since it is left aligned, 9876 is printed here. 2 blank spaces are, or here it is there. So because of that, the next number I am displaying, it is coming after the 2 blank spaces. Okay. For the last message, 06D and left aligned. Sorry, right by default right aligned. So for the last message, it is coming as right aligned only. So to see that, I will restore that slash n. So it is coming as right aligned, and the first two blank spaces, similar to here, it is filled with zeros, because I have mentioned percentage 060. Okay. So practically these things, you may not be using these facilities as much, but maybe occasionally when you are doing some program, the output, very clear specification is there. The output should be displayed with the preceding zeros, say 6-digit preceding zeros, like that. If it is specified, you might use it. Otherwise, not much of practical use I see for this. Okay. So this is about for displaying integers. We'll move on quickly to real numbers. In real numbers, the output format is w.p. w.p. Normally it is uh, what did I do? Yeah. So normally it is percentage f. Okay. But when we are displaying real number, the general format is percentage w.p. W stands for the width. How many fields to be reserved on the screen, same as the integer case. And P stands for the precision. We already used this feature before. We wanted to display the area of a triangle with a 2-digit precision. So W width is also there and precision is also there. So this is width, or the how many cells are required for displaying the number. Cells are to be reserved for displaying that number, including the decimal point. Including the decimal point, what is the width or number of cells to be reserved on the screen. Precision is after the decimal point, how many digit precision we want. That is the use of precision. Now I have an example here. Percentage f. I am not using anything. I am any w or p, both I am not using. So if by default it will be displayed with 6-digit precision. So 2.3 and 5 zeros. Okay. Now if I want to restrict it to 3-digit precision, I will specify 0.3. This we have used in our lab programs. So it will, even though my number is having less precision, when it is displayed, additional zeros will be added to the right, so that it is made 3-digit precision. Okay. So we'll see the rest of the cases. So I have a floating point number and initialized with 98.7654, and W value is 7. That means total 7 cells will be reserved. Including the decimal point, total 7 cells will be reserved. Now precision is 4. That means after the decimal point, 4 digit needs to be displayed. Okay. Now if I change the value slightly, 7.2. W is 7, P is 2. In that case also 7 cells will be reserved, but when it is displayed, it will be displayed as with the 2-digit precision. So some round off will happen here, rounding off will happen here, and output may be displayed as 98.77, 2-digit precision. Now this is by default right aligned. We have reserved extra cells and we are not consuming all of them. Only 5 out of 7, 5 cells are consumed, including the decimal point. Now if we want it in a left aligned manner, we can put minus 7.2 F. So this is coming as left aligned manner. Then default. Okay. So default, I think it should be coming with 6-digit precision. Yeah, but I am reserving. Okay, this may be. I think it should come with 6-digit precision. Let's see. One, two, three, four. Yeah, it is coming with 6-digit precision. 94th one. 1, 2, 3, 4. So 5430. Yeah. So here there is a small change. So what I can do is I can slightly change it to 0.4 so that the output is correct. So 4-digit, I'll change it to 0.4 so that the output is correct rather than inserting 2 extra cells here. It takes some effort now. Okay. So 0.4 with the 4-digit precision. Then there is another, instead of F actually we can use E also. If you want exponent notation for a real number, there is a decimal point notation as well as a Mandisa exponent notation is there. So if you want to display it in Mandisa exponent notation, we can use E. We rarely use that, but there is a provision for that also. Instead of S percentage F, we can use percentage E. Here 10 spaces are reserved and precision is 2. So the Mandisa part 2-digit precision, total 10 spaces reserved, and the exponent part is E followed by the exponent part. Now here 11 spaces are reserved and the number we are displaying is a negative number. We simply apply minus onto that. So including the sign, 11 spaces are reserved. Precision is 4. So 4-digit precision and the exponent. Okay. So how it is displayed here when I am using E. So far I did not mention it. It was not so important, but a floating point number you can represent using your regular floating point notation or your Mandisa exponent notation by changing F to E. So if I do that, the number will be displayed in this manner. Okay. So we rarely use that, but just remember it is also possible. Somewhere if you find this kind of output, it is because percentage E is used instead of percentage F. Okay. So that is about real numbers. Characters, general format outputting. We are seeing the formatted output, basically how we use it in printf. So characters percentage WC similar to integers, and it looks like this. By default percentage C, and you pass the character variable, only one cell required for one character, it is displayed this way. Reserve 6 fields but only one character to be displayed. It will be displayed. 6 cells are reserved, but one character is displayed in a right aligned manner towards the rightmost cell. Minus 4C, 4 cells are reserved. In a left aligned manner, the character is displayed. Similar to integer. But here only one character is there. Integer, there can be multiple digits and they will fill out the cells. Character is clear? Any doubt? Next is, yeah,
No, sir, no doubts.
okay. Next is strings. String is somewhat, so character is somewhat similar to integer, percentage WD, percentage WC. Now string is somewhat similar to floating point numbers or real numbers. General format is percentage W dot P, W dot P, where W stands for the width, P stands for the precision. Here precision meaning is slightly different because it's a string. Precision here means the number of characters to be reserved. Number of characters to be reserved. I mean displayed. Number of characters to be displayed. So W total cells reserved. P number of characters displayed in that total cells. So I have an example here. Do I have an example here? I think I don't have an example to demonstrate. Okay, doesn't matter, but it is from the examples I have given here, it is clear. So I have a string. String is, it is a array of characters. We create a set of character variables and we can store a string in that. So either using scanf statement or I can directly assign like this. Char str square bracket 20 means up to 20 characters I can store in str. And I am initializing with a string constant. Anything within double quotes is a string constant. So this is 5, 6, 9, 11 characters. So out of 20 variables here, character variables here, I am utilizing only first 11. That's it. Now if I am displaying usual way, percentages, all the characters will be displayed with a space in between. Here there is a space. Now if I use percentage 15 as precision, I am not specifying, width I am specifying. So 15 is for W. That means total 15 cells are reserved. Out of that, the string is displayed in a right aligned manner. Now here I am specifying width as well as field width as well as the precision. So 15 cells will be reserved, but only 5 characters will be displayed. So this is the output. If total 15 cells, since I specified 0.5, out of hello world the entire string, only 5 characters are displayed. Here I am not specifying any width value, field width value, but I am specifying 0.5, only 5 characters, 5 cells reserved, 5 characters are filled in those cells. Now if I want it in a left aligned manner, I can use minus 15.5s. So this is right aligned version, 5 precision, that means 5 characters. Here also 5 precision, 0.5 is used as the precision value, so only 5 characters, but because it is negative here, it will be displayed in a left aligned manner. Okay, so this is about string. Normally you will get a question like this, either on floating point number or integer or string. So certain statement will be given like this and you will have to display the corresponding output. Here also, what will be the output or how the output will be displayed? You can show it by drawing the cells and filling the digits there. Clear? Mixed data output, we are think similar to mixed data input, we specify percentage D, percentage C, percentage S, percentage F, like that. Mixed data, and we can specify W here for this, like that. W point P here we can specify. Okay. Then enhancing some guidelines for enhancing the readability of your output or beautification of your output. Provide enough blank space between two data items. If you are displaying two data items in a single line, provide enough blank spaces. Introduce appropriate heading and variable names. Print special messages whenever peculiar conditions occur. Say divide by 0 is there, you print a message, divide by 0. Or any special scenario is there, you print a message. Introduce blank lines between important sections of the output. Some guidelines for making your output display screen look nice. Here I have put an example. So I have added many percentage n, percentage t. See name, age and field. These are the titles of the data, title field for the data I am going to display. I am going to display a table kind of data, or each column is named name, age, ID, and I am specifying tab in between. Rather than blank spaces, leaving blank spaces, I am specifying tab in between. So now when the output is displayed, it is nicely coming, right? So output results, the same thing when I am executing, this is how I get the output. So it is aligned actually. The columns are aligned, left aligned. So it looks nice rather than putting blank spaces, it looks better. So you can try out these things. Okay. Comes like this. Okay. Suppose if I remove this, instead of tab, I'm putting some spaces, but tab is taking care of properly aligning it. So if I remove this tab and simply put space, it's not going to come so nicely. So this first two lines you see, it's not aligned properly. Okay. So it is advisable to give tab in between the data. But in your lab experiments, it may not be based on tab and all, but there you have to match with the expected output rather than when you are doing in a freeform editor, not the lab experiment, you can experiment these kind of things. With that, we are concluding with the topic input output in C, input output mechanism in C. We have seen formatted input output and unformatted input output statements, integers, real numbers,